Hey everyone! If you're sitting for your A-level physics paper 5, this is your final boost to secure those last marks. In this video, I'm going to break down exactly what Cambridge wants from you in planning, analysis, as well as evaluation. Whether you are aiming for a great boost or you're struggling with the uncertainties and graph work, I have got you covered. Plus, I'm giving you a free Paper 5 PDF with suggested instruments together with the detailed methods on how to use the instrument and exam rating phrases. Format for the question link is in the description. Just go to the link and just download the PDF. Right, ready? Let's dive and finish this strong. Now, this is it. A-level physics 9702 is the code, paper 5 final boost. Ready? Let us get started. First, understand the format. Before you even start answering question paper 5, right? Questions in paper 5, you need to understand the formats. So first of all, the first question is about planning experiment. How do you plan an experiment like a physicist? Right, you are the planner. So for the future student to conduct the experiment. And second question is about the analysis plus evaluation. Now, I would like to give you so many tips here. Tip number 1, yeah, you have to master in your experimental variables. So for the planning experiment, you need to know your variables. Right, there are 3 variables altogether. First one is your independent variable. Second is your dependent variables, and the third one is are your variables to be kept constant or controlled variable. Now, first of all, before you even start to plan your experiment, after you read the question, always identify your independent variable, dependent variable, and your variables to be kept constant or your controlled variable. How to determine all these variables easily, right? Some people, they struggle. Some of the students, they struggle. Which is my independent variable and which is my dependent variable? What are my variables to be kept constant? Don't worry. Right? First of all, understand what is independent variable. Independent variables is the physical quantity that can be changed easily. You want it to change to this value, it could change easily. You want to alter this, you can alter it very easily. Right? The dependent variable is the physical quantity that will respond to the changing physical quantity. So dependent variable actually depends on independent variable. So once the independent variable is changing, dependent variable will change according to the changing of independent variable. Sound confusing, right? Don't worry, I will give you some examples. Right? So variables to be kept constant, they are variables, but when you are conducting the experiment, you want to keep them the same throughout the whole experiment so that the dependent variable will change due to the independent variable. So in other words, I'm saying that independent variable will be the only one that will affect the dependent variable. Right. Now, let me give you one example from the past years. Right. This is one of the past year questions. A spring, look at the spring, is attached to a strong cylindrical magnet of length L and cross-sectional area A. Magnet is placed on a thin cord on top of magnetic sheet on the bench. Could you see that? They have already drew out everything for you. As shown in Fig 1.1. Thickness of the cord is T. Magnetic flux density at one of the poles of the magnet is B. Now remember, magnetic flux density means magnetic field strength. Right? A force is applied outwards. You have to apply the force to the spring. Right? Pull it up. Right? So I better write it here. Pull out the spring. F is acting upwards. Extension of the spring when the magnet just leaves the cord is S. Right? So you want a magnet to leave the card. Once the magnet leaves the cards, the extension of the spring, that is S. Now, first of all, question, it is suggested that S is related to T by the relationship Ks is equal to AL BZ over T. where K is the spring constant of the spring and Z is the constant. Plan a laboratory experiment to test the relationship between S and T. So I want you to see this. Isn't this very clearly stated by the question that you have to plan the experiment to test the relationship between S and T? So either one of these two physical quantity will be your independent variable and the other one will be your dependent variable. Now, go back to the question. Which one that you think, which physical quantity that you think is easier to alter? Compare, okay? S is the extension of the spring. Extension of the spring, you cannot just read it just like that. You have to determine the initial length of the spring and the final length of the spring. Then only you find the difference between initial and final length of a spring to determine your extension. This is so troublesome, don't you think so? So I would not choose S to be my independent variable. What about T? Oh, T is just the thickness of the card here. So if I want it to be thicker, so I slot in more cards so that it could be thicker. Don't you think that is very easy to alter? So that is why I choose my independent variable as T, the dependent variable as S. And what about the variables to be kept constant? Look at the equations given. Apart from S and T, right, and Z, because you're supposed to determine the value of Z, right? You're supposed to determine Z in this experiment. So you cannot write Z as your variables to be kept constant. You don't know Z. You're supposed to determine Z, right? So apart from S, T, and Z, all the physical quantities given in the relationship are your variables to be kept constant. So K, L, A, and B. Now, tip number 2. Bear in mind, you have to write a clear method. What do I mean by clear method? You have to describe each and every step as clearly as possible. Don't leave question marks in the examiner's head. Right, as if you're the one that conducting the experiment and you want this experiment to be as successful as possible. First step, you have to do this. Second step, you do this. Third step, you do that, etc. Right? So you have to include the instrument that you use for your measurement. Maybe, okay, in this case, in the previous experiment that I gave you, you want to measure the thickness of the card. And look at the diagram given. Thickness of the card. Should I use meter rule? No, because the card seems to be quite small and the thickness is quite small, right? Instead of using meter rule, you might want to suggest micrometer screw gauge, right? And then how to measure measurement technique, right? So don't worry about this because I have already got you covered. I have sent you the link to my PDF paper 5, which I discussed very, very detailed and how to use the instrument to do your measurements. So all you need to do is just to download and how to vary the independent variable, right? Because you need to get a set of readings in order for you to plot the graph. Remember, right? You have to suggest a student to plot the graph. Now, look back at this question, right? When I do my methods, okay, I will give you my suggested method. This is my suggested method. First one, I drew a diagram, which I'm going to show you later. So you tell the examiner, being polite, to refer to the diagram that you have drew. Set out the apparatus as shown in the diagram, which I'm going to show you later. Initial length. Remember, we are supposed to measure S. S is the extension of the spring. So before I find the extension of the spring, I need to measure the initial length of the spring. Tell the examiner initial length. What is the instrument that I'm supposed to use to measure the initial length? So I'm supposed to use a meter rule. And what about the thickness? Remember just I told you, thickness can be measured by micrometer screw gauge. And I even suggest, if you don't want to suggest, it is not a problem. Don't suggest if you don't want to, right? Doesn't matter. Just tell, okay, I measure T by using micrometer screw gauge and put a full stop, right? And then the force, okay, if you don't want to give a value of the force, it doesn't matter. Just tell, how do I measure the force, right? So outward force must be applied to the spring, remember? So the force I measured using Newton meter or Newton spring balance, right? And then after that, once you apply the force, remember, the spring will extend. So all you need to do is just to measure the final length of the spring by using a meter rule, same meter rule, right? So S, which is the extension of the spring, can be easily calculated by final length of the spring minus the initial length of the spring. Then last point of the method, always tell, right? Experiment, always repeat the experiment with maybe thickness is equal to, or if you don't want to suggest any values for the thicknesses, never mind. Just say, repeat the experiment with different thicknesses of the card. That will do. Now, tip number 3 is about your label diagram. Right, draw a simple label diagram. No need to be artistic. I'm not artist as well. I draw a very ugly diagram. Oops, okay? But make sure that you just don't leave once you have draw your diagram. Always label your apparatus as clearly as possible. Don't leave it blank like that and expect we know what kind of apparatus that you're drawing, what diagram that you're drawing must be labeled. A diagram, no matter how nice it is, without label, you will get 0 mark. Remember that. Now, the same question, I keep on discussing the same question because I don't want you to confuse, right? Look at the question here. This is my diagram, right? So I have a retort stand because ruler cannot stand by itself. I need to climb the ruler, but there's a distance between my ruler and spring. That is why I need a guide to give me the reading on the meter rule. I cannot just use my eyes and look at the reading and predict the reading. No, I'm not a person to predict something. So you use the set square, add as a guide. Right, there is my spring. Quite ugly. I'm not artist, you see. And the Newton meter, you apply the force, right? And I don't want everything to fall apart. That is why I want to secure my magnet, right? And the card. So I use a G clamp to clamp them to secure their position. And another set square, which is set square 1. If you see this, set square 1, I use it to make sure that my meter rule is vertical. 100% vertical. Set square 2 is used as a guide to take my reading of the final length and initial length of the spring. Now, tip number 3, additional details and the safety precautions, right? Additional details and safety precautions are quite important. They give you quite a lot of marks, right? Altogether 6 marks. So you have to mention how to control the variables. So you have already mentioned, right, the variables to be kept constant, right? How do you want to keep them constant? So maybe mention 1 or 2, that would do. Right? So example, right? I say that, you see, diameter of the spring. I measure it by using micrometer screw gauge. And I want to keep my surface area or the area of the spring, right, to be constant all the time. I don't want my area, surface area of the spring to change. So I tell A can be calculated by equation pi d squared over 4. Right, because I don't know. I cannot use any apparatus to measure area. Area must be calculated. So this is what we call additional detail. You give more detail on how to calculate your area. Right, because at the end of the time, suggested equation, you have to put in area of the spring to do your calculations. Right? Or you can also say from my diagram, you can see that I use G clamp. What is the function of the G clamp? I use G clamp to make sure that everything is secure in their position, right? The spring is the magnet is not leaving the bench, right? So I want everything to be static, stationary. So I use G clamp to secure, right? The magnetic sheet to the bench. Right, tip number 4, right? Data analysis like a pro, right? So first of all, second question, you have to read your question carefully. So because the second question is about analysis and evaluation. Read each and every word carefully. Take your time. And then identify the x-axis and your y-axis. Right? And then if you need to, you have to modify the equation to match the straight line equation. Now, straight line equation is y equals mx plus c. M represents the gradient, c represents the y-intercept. So example, you could see that it is suggested that this is another question. V and T are related by this equation. Right? V is equal to Q naught over C, E exponent to the power of negative T over RC. So a graph is plotted on ln V on the y-axis. You see the equation given is not related to ln, so you have to do some modification on the y-axis against t on the x-axis. So you have to make your ln v on the left-hand side. right? To match the straight line equation. And you determine the expression for the gradient and the y-intercept. So you have to give that. So I modified my equation. I ln both sides. When I ln v, I get ln v on the left-hand side. And I ln q naught over c. I get ln q naught over c. When I ln and exponent, you cancel. So you bring down the power, negative t over rc. And now make some modification because y-axis has to be ln v. T must be on your x-axis. So this is x. Can you see that? Y equals mx plus the whole thing here, ln q naught over c is your y-intercept. Can you see? The gradient can be easily identified. So the gradient is negative 1 over rc, whereas y-intercept is ln q naught over c. Right? Make sure that you know how to modify the equation. Right? That's all. Now, tip number 5, read the table carefully, right? The calculation of your absolute uncertainties. Now, absolute uncertainties have already been covered in your AS syllabus. You can also use the knowledge from the AS syllabus on how to calculate the absolute uncertainty to deal with your absolute uncertainty in your paper 5, right? But I have easier method to do, right? Which I'm going to guide you in this video. Could you see that? Calculate and record values of ln V slash V is the unit of ln V, right? Is the unit of V. In table 2.1, include the absolute uncertainties in ln V slash V. Now, when the question mentioned that you have to include the absolute uncertainty, first step you do is that you add. Okay, I want you to do this. Put plus minus in between. That's all. Make sure that you put plus minus in between everything here. And after that, look at the question again. The question wants you to record ln V together with the absolute uncertainty. Second step, find the absolute uncertainty first. And I am going to stick to AS rule that stated that absolute uncertainty can only put in one significant figure. And I will stick to that rule. Now, this V, ln V depends on V. Yeah? Look at the V values. Okay, I don't want to, this 6.2 plus minus 0.2. It means that this V value is split between 6.4, two extremes. 6.2 is an average value, right? And 6.0. Yeah, you plus 0.2, you get 6.4. You minus 0.2, you get 6.0. Right? I want you to, easier way, I want you to use average value and maybe the highest value or the lowest value is up to you. But don't use between the two extremes because you have to divide two. That's very tedious for me, right? Only focus on the average value and the highest value. Okay? Now, after that, what you do, next step, since they ask you to find ln, okay, I'm not going to use the AS method to deal with my absolute uncertainty. I'm going to teach you the easier way to do this, right? How you're supposed to do for this one, okay, you just put ln 6.4 minus ln 6.2, the average value, okay, get a value. Now, ln 6.4 minus ln 6.2, hold on, ln 6.4 minus ln 6.2, get a value. I got 0.03. Remember what I told you? I'm going to make sure that my absolute uncertainty, I'm going to stick it to one significant figure. Follow the AS rule. So my answer here is 0.03, 1 SF. Right? So I just put it here, 0.03. And the next value, right? You use ln 4.6 plus 2 is 4.8. So you use 4.8 and 4.6. Ln 4.8 minus ln 4.6. Get a value? Ln 4.8 minus ln 4.6. Get a value? I got 0.04. 1 SF. And the next one, 3.4 plus 0.02. 3.6. Right? Then use the value of the highest value, ln 3.6 minus ln 3.4. ln 3.6 minus ln 3.4, that gives you 0.06. 1 SF. Here, the next one, 2.6 plus 2, 2.8. So use ln 2.8 minus ln 2.6. Ln 2.8 minus ln 2.6, and you got 0.07. Next one, 2 plus 0.2, you get 2.2. So you use ln 2.2 minus ln 2. Ln 2.2 minus ln 2, and you get 0.1. Wow, I rounded off. 0.1. And the next one, 1SF. Actually, the answer showed by the calculator is 0.0953. So I round it off to one significant figures. That will be 0.1. So this is 1.4 plus 0.2. That gives you 1.6, right? So ln 1.6 minus ln 1.4. So I got 0.1 as well. So I want you to see this. Maybe some of the students think that, oh, how come the first 1, 2, 3, 4, 4 readings you put it in terms of 2 decimal points, and then after that the last 2 readings you put it as 1 decimal point? Because I stick to the rule of AS, right? I follow the rule of AS, which is final answer for the absolute uncertainty is one significant figure. I follow the significant figure. Right. Now, once you have done with your absolute uncertainty, calculate your ln V. Your ln V, you just look at your average value. All these, the ones that are highlighted green, right, are the values that you're supposed to use for your ln V. Right. Now, ln 6.2. I got 1.824549, right? But, okay, before you write down, right, record the reading of ln V, I want you to bear in mind, the value, since the absolute uncertainty is included, your reading must follow the decimal point of your absolute uncertainty. So 0.03, that is 2 decimal points. So your reading, you put it in terms of 2 decimal points, which is 1.82. Now, the next one, ln 4.6. Look at the absolute uncertainty. It is in 2 decimal points. So I put it in terms of 2 decimal points, which is 1.53. Ln 3.4. Look at the absolute uncertainty. It is in terms of 2 decimal points. So that is why I put 1.22, 2 decimal points. Ln 2.6. Look at the absolute uncertainty of 2.6. I got 0.07, which is 2 decimal point. That is why I put it in terms of 2 decimal point. 96. Ln 2. Look at ln 2, right? Ln 2, look at the absolute uncertainty. There is 1 decimal point. So record it in terms of 1 decimal point, 0.7. Follow the decimal point of the absolute uncertainty when you include your absolute uncertainty. Right? Absolute uncertainty is the one that determines the decimal point of your ln V when it is being included. If it is not being included, you just follow the significant figures of your raw data, which is V. Right? Now, the next one, ln 1.4. Since 1.4 has 1 decimal point, so I put it in terms of 1 decimal point, 0.3. That's it. Should you have any hesitation, do not hesitate. Just comment below. Right, the next one is about your gradient and your best fit line, right? So draw a smooth, straight best fit line. And then to calculate the gradient, make sure that you use a triangle that covers at least half of the line. So that means the triangle must be drawn at least as covered, right? Half of your straight line, the best fit line, right? Show the coordinates on the 2 points that you use to calculate your gradient, and then the gradient calculation, right? y2 minus y1 over x2 minus x1, right? And an important tip here that I want to give you is that make sure that you always start with question number 2 first, because the time is limited for your paper 5. It is given 1 hour 15 minutes only, so you will be using a lot of time to plan your experiment, because this is not just you read the question and you know what to do. Sometimes you need to think, and the time, yeah, is running out. So that is why first thing, you get your paper 5, go to question number 2, ignore question number 1, and spend only about 20 to 25 minutes in answering question number 2. Answer as accurate as possible with no mistake, because the mistake occur, that means you have to erase everything. So that would be very, very messy. We don't want that to occur. Stay calm. Okay. Once you have already answered your question number 2, the rest of the time use it for planning experiment. Right? So the final advice that I would like to give you is that, right, practice using the real past year paper and time yourself. Give yourself, instead of 1 hour 15 minutes, maybe you want to give yourself 1 hour, right? Time yourself. Okay, so that is all your final boost. Now you know how to plan like a physicist, right? Analyze the data accurately and impress the examiner with your strong evaluation. If this helped, like the video, subscribe to my channel, and drop a comment if you want help with any specific question type, right? Stay sharp, trust your patient, right? Trust your practice and go ace that examination. All the best. See you in my next video. Bye.